Let's look at another example where we're making it a little bit more complicated here. Looking at our next equation, 40 times e to the power 0.6x equals 240. I do not get to apply the log right away because I have a coefficient in the front, 40. I need to get rid of that 40. Let's start out with dividing both sides by 40 so that we can get rid of that 40 in the front. We can cancel. And we have e to the power 0.6x. E to the power 0.6x equals 240 divided by 40 is 6. And because my calculator can handle natural logs, I'm just going to go ahead and use a natural log here. Natural log e 0.6x equals natural log 6. And the natural log and the e are inverses of each other, so when they get together they cancel, and we're just left with the exponent 0.6x equals natural log 6. And I want to solve for x, so we divide by that 0.6. X is equal to natural log 6 divided by 0.6. That's our exact answer. If we're doing an approximate, we can pull up our calculators. Natural log 6 divided by 0.6 will give us 2.986 as our approximate answer. We can check. Checking our work, we go back to the original equation, 40 e to the 0.6 times 2.986, does that approximately equal 240? So 0.6 times 2.986 gets me 1.7916, and then we'll say e to the power 1.7916, 5.999 multiplied by 40, we get 239.96. And because we rounded the 2.986, we're not getting exactly 240, but we're getting something really close. So this makes sense. This seems reasonable that our 2.986 approximation is the right answer for our problem. Let's review some steps for solving exponential equations. We first isolate that exponential expression so the base is by itself. Base to the exponent is by itself. We can take a log of both sides of the equation. This can be natural log or common log or log of the base that we're working with. Remember, there are two methods we can use. We can either apply that inverse property and use the log of the same base that our exponential expression is, or we can use any log, primarily natural log or common log, because that's what our calculators can handle, and apply a log to both sides so that we can be able to use those log properties. We'll simplify using the log property that deals with exponents, and we solve for the variable. We're going to want an exact answer and an approximate answer, so make sure you get both. And then we do want to check. We can always make mistakes, accidentally copy an answer and copy a number down wrong, switch a decimal around, divide, or subtract, or do any operation and get a slightly wrong answer. So we always want to check our answers. But for exponential equations, all answers should be solutions because the domain of our exponential functions is all real numbers. Every exponential function has the domain of all real numbers, so all of our answers should be solutions. Let's work on some. Taking the first one, 10 to the power x equals 3.91. Since it's base 10, we can use log base 10. And then log base 10 and 10 are inverses, so they'll cancel each other out. And x equals log of 3.91. This is our exact answer. If we want our approximate answer, 3.91, take the log. 3.91, take the log. We get 0.592. So our approximate answer, 0.592. We can check this. 10 to the power 0.592 should give us something close to 3.91, 3.908, and it does. Gives us something really close, which is what we want. Looking at the next one, e to the power x equals 5.7. The log with a base e is natural log, so let's use natural log. Natural log e to the power x equals natural log of 5.7. Natural log and e are inverses, so they will cancel each other out, and we're left with x equals natural log 5.7. This is our exact. Pull up our calculator. 5.7 natural log, we get 1.740 for our approximate. And we can check it. E to the power 1.740 should be something close to 5.7. And it is 5.697. It's close to 5.7. It works. Doing another one, 19 to the power x equals 143. I'm going to apply any log to this one just so that I can bring the x down. So I'll do log base 10. Any log to both sides. I can bring that exponent down front. X log 19 equals log 143. Log 19 is just a number, so I can divide by it. And dividing by the log 19 on the left gets rid of it. X equals log 143 over log 19. This would be our exact. If we were applying log base 19 to both sides, just as a little side note, our exact answer would look like that. X equals log base 19 of 143. But remember that change of base formula will give us what we have here. And this is our exact answer. Approximate means we've got to use the calculator. So 143, apply the log, divide by 19, apply the log, and hit enter. We get 1.685 as our approximation. And we can check it. Always good to check. And it doesn't take that long with these equations. 19 to the power 1685 equals 142.79, really close to 143, and that's what we wanted to see. I'll leave you to try number 7 on your own, see if you can find out what x is.